Gabriel's thalamide synthesis. Suppose this is one compound. Look at this one. One benzene connected with CO and NH and another CO. This is a cyclic compound. It is called thalamide. Thalamide. When thalamide is treated with KOH, the H will be replaced by K. H alone will be replaced by K. This is called potassium thalamide. It is called potassium thalamide. When it is treated with alkyl halide, the K will be replaced by R. So you are getting NR. This is called N-alkyl thalamide. N-alkyl thalamide. When N-alkyl thalamide is treated with KOH, these two bonds have been broken, and you are getting one compound like this. Potassium salt, and this Rn combined with hydrogen to form RNH2. You have got a primary amine and the last compound is called potassium phthalate. Potassium phthalate. Potassium phthalate. So this is called Gabriel thalamide synthesis, a very important reaction in this chapter. Thalamide, let's see once again from the beginning. Thalamide having an H treated with KOH, the H is replaced by K, and you have got potassium thalamide. Further it is react with RX, so K is replaced by R, you are getting N-alkyl thalamide. Further treated with KOH, you are getting the primary amine at the end. By this method, the primary amines are efficiently formed. The amines are having the extra electrons. That's why they are called basic. Simply, they are called Lewis basic. All these bases reacts. All the amines, since they are basic, they can easily react with acidic materials. For example, the methylamine is there. CH3NH2 is called methylamine. Suppose it is treated with HCl. One addition reaction occurs. Here, how many hydrogens are there in methylamine? 2 hydrogens. It combined with H, and you are getting CH3, NH3 plus Cl minus. You have got one ionic compound. Basically, it is ammonium chloride. See, ammonium chloride. Basically, ammonium chloride, one of the hydrogen is replaced by methyl group. This is nothing but this. So basically ammonium chloride and having one methyl group. That's why it is called methyl ammonium chloride. Methyl ammonium chloride. Now let's see the other reaction. Suppose it is reacting with HNO2. HNO2 is called nitrous acid. When methylamine is treated with HNO2, the amino group is converted into alcoholic group and you are getting CH3OH plus N2. The nitrogen is liberated. HNO2 acid. Have you seen nitrous acid in your laboratory? You could have seen nitric acid, sulfuric acid likewise. You could not have seen nitrous acid. Nobody could have kept nitrous acid in one bottle or any of the laboratory because it is highly unstable. Nitrous acid is highly unstable. As soon as it forms, it decomposes. Then how will they use in this reaction? Since it is highly unstable, we can't add HNO2 directly. Instead of that, instead of adding HNO2, they are adding NaNO2 and HCl. When NaNO2 and HCl have been added, H combined with NO2 to form HNO2. So instead of adding HNO2, they are adding sodium nitrite and HCl. In the spot itself, HNO2 has been formed. And in the spot itself, HNO2 reacts. That's why in French, it is called as, it is prepared by in situ method. Nitrous acid is formed by the method called in situ method. In situ is a French word. In situ means in the spot itself it has been prepared. So, the very important concept is nitrous acid converts primary amine into alcohol. Nitrous acid converts primary amino group into the alcoholic group. Now let's see how the nitrous acid affects secondary amine. This is the secondary amine. Suppose it is treated with HNO2, nitrous acid. While treated with nitrous acid, you are getting a compound like this, CH3 twice, N, single bond N, double bond O. You have got a compound like this. It is called N-nitroso dimethylamine. N-nitroso dimethylamine. It's a yellow oil. It's an yellow oil. It is insoluble in water. So, when secondary amine, that is dimethylamine, reacts with nitrous acid, you are getting N-nitroso dimethylamine, which is a yellow oil insoluble in water. Let's see the tertiary amine. Tertiary amine, 3 methyl groups are connected. Trimethylamine. When trimethylamine is treated with nitrous acid, you are getting this compound, trimethyl NH plus NO2 minus. Trimethyl ammonium nitrite. Trimethyl ammonium nitrite, ITE. This is a salt soluble in water. Understood? Now we are going to see another important reaction involving in amino groups. That is carbylamine reaction. Carbylamine reaction. Carbylamine reaction is a test for primary amine. When primary amine is treated with chloroform CHCl3, chloroform, and potassium hydroxide KOH. When methylamine is treated with chloroform and KOH, you are getting CH3NC. Methyl isocyanide, and you are getting 3KCl plus 3H2. You are getting methyl isocyanide. Methyl isocyanide. The methyl isocyanide is not having pleasant smell. It's a foul smelling compound. Offensive odor. This is called carbylamine reaction. Only primary amine can undergo this reaction. It is the speciality. Another one is called mustard oil reaction. Mustard oil reaction. Probably the product may have the smell of mustard oil. Pungent mustard-like odor. Carbon disulfide has been treated. It is methylamine and it is called carbon disulfide. When methylamine is treated with carbon disulfide, you are getting CH3NC. Actually, double bond involves plus H2S. Its name is methyl isothiocyanate. Methyl isothiocyanate. Methyl isothiocyanate. So this is called mustard oil reaction. Sometimes benzaldehyde react with methylamine. Benzaldehyde. Benzaldehyde reacts with methylamine. While doing so, it is connected like this, NCH. It is called Schiff's base. Schiff's base. It is called benzol N-methyl benzol N-methylamine. Benzol N-methylamine. It is called Schiff's base formation. So far we have seen aliphatic amines. Now let's go to aromatic amines. C6H5